Demystifying Spring Boot, a practical guide for modern Java development. 1. Welcome to the reactor. Unveiling Spring Boot. Imagine standing at the edge of a vast, complex machine. It hums with power, thousands of intricate parts moving in perfect, synchronized rhythm. This machine is the engine of countless modern applications, from the apps on your phone to the services that power global businesses. This machine is Java, one of the most widely used programming languages in the world, especially for large, enterprise-grade systems. For many years, building applications with Java, particularly for the web, was like assembling that complex machine from scratch every single time. You'd gather the engine, the chassis, the wiring, the seats, and then spend painstaking hours connecting each piece, configuring every setting just to get the basic structure ready. This process, while empowering, was often slow, repetitive, and prone to errors. Developers spent a significant portion of their time on boilerplate setup rather than on the creative, problem-solving work that truly brings an application to life. This is where Spring Boot enters the picture. Think of Spring Boot not as a completely new machine, but as an incredibly advanced, assembly line robot that streamlines the entire car manufacturing process. It sits on top of the well-established Spring framework, the foundational tools and rules that many Java applications rely on. While the Spring framework provides the components and the blueprint for building powerful applications, Spring Boot provides the speed, the simplicity, and the pre-assembly required to get those applications up and running with astonishing efficiency. The problem Spring Boot solves, the legacy complexity. Before Spring Boot, setting up a new Spring application involved a multitude of manual steps. Configuration overload. You'd spend a lot of time writing extensive configuration files, often in XML format, just to tell your application how to connect to a database, how to handle web requests, or which security settings to apply. This was tedious and error-prone. Dependency management headaches. Modern applications rely on dozens, sometimes hundreds, of external libraries. Keeping track of compatible versions for all these libraries and manually adding them to your project was a constant chore, leading to frustrating conflicts. Deployment pains. Getting your application ready to run on a server often meant complicated steps like installing a separate web server, like Apache Tomcat, configuring it, and then deploying your application to it. It wasn't a straightforward process. These challenges meant that the initial barrier to entry for developing robust Java applications was quite high, and the time to market for new features could be slow. The Spring Boot advantage. Ready to drive simplicity. Spring Boot was created by a team at Pivotal, now part of VMware Tanzu, and first released in 2014 with a clear mission: to make it incredibly easy to create standalone, production-grade Spring-based applications that you can just run. It achieves this through several core principles. Speed and productivity. Spring Boot drastically accelerates development. You can literally get a basic, fully functional web application up and running in minutes, allowing you to focus on writing your unique business logic rather than wrestling with infrastructure setup. Analogy: imagine you're building a new restaurant. Traditional setup would involve constructing the building, designing the kitchen, installing plumbing and electrical systems, and then hiring and training staff, all before you can even think about cooking. Spring Boot is like getting a fully equipped, prefabricated restaurant building with all the essential appliances already installed, inspected, and ready to go. You just need to walk in and start cooking your specialty dishes. Convention over configuration, opinionated approach. One of Spring Boot's most defining characteristics is its opinionated nature. This means it makes smart, sensible default decisions on your behalf. For example, if you include a web library, Spring Boot will assume you want to build a web application and automatically configure an embedded web server, like Tomcat or Jetty, for you. Similarly, if you include a database library, it will try to set up a basic connection automatically. The powerful aspect here is that, while Spring Boot provides strong defaults, it also offers complete flexibility. You can always override any of its conventions with your own specific configurations if your needs differ from its assumptions. It's like a highly intelligent personal assistant. It anticipates your needs and handles routine tasks, but it always lets you take the reins when you have a specific preference. Standalone, executable applications. In the past, deploying a Java web application often meant generating a special file, a WAR file, and deploying it to an external, pre-installed web server. Spring Boot revolutionized this by allowing you to package your entire application, along with an embedded web server, into a single, executable Java archive, jar file. This means you can run your application directly from the command line with a simple Java jar your application name jar command. No separate server installation is needed. This vastly simplifies deployment and makes your application highly portable. Simplified dependency management, starters. Remember the headache of managing compatible library versions. Spring Boot introduces starters. These are special, convenient dependency descriptors that bundle together common, compatible libraries for a particular feature. For instance, the Spring Boot Starter Web dependency brings in everything you need to build a web application, Spring MVC, an embedded Tomcat server, JSON processing libraries, and more, all with harmonious version numbers. Analogy: instead of buying hundreds of individual Lego bricks and a separate instruction manual, you buy a Space Shuttle Lego kit. This kit contains all the specific bricks you need, in the correct quantities and the instructions, eliminating the guesswork and ensuring everything works together perfectly. The Spring Boot Starter Web is your ready-to-assemble web application kit. Production-ready features. Beyond just development, Spring Boot includes built-in tools for managing and monitoring your application once it's deployed. Features like health checks, metrics collection, and live environment inspection through Spring Boot Actuator are readily available, making it easier to maintain and understand your application's behavior in a production environment. Spring Boot's impact, a catalyst for modern development. Since its introduction, Spring Boot has rapidly become the de facto standard for building new Java applications, especially for microservices architectures. Its ability to quickly create small, independent, and easily deployable applications made it a perfect fit for the microservices trend, where large applications are broken down into many smaller, manageable services that communicate with each other. Cloud-native development. The self-contained, executable JARS and its flexible configuration mechanisms align perfectly with the demands of cloud computing platforms and containerization technologies like Docker, allowing applications to be easily packaged, deployed, and scaled in cloud environments. In essence, Spring Boot took the proven power of the Spring framework and wrapped it in a layer of simplicity and convenience, allowing Java developers to be more productive and agile than ever before. It empowers you to go from an idea to a running application with remarkable speed, truly getting you to the reactor of your application development with minimal friction. In the next chapter, we'll get our hands dirty and set up our very own Spring Boot development workshop, equipping you with all the tools necessary to begin your journey. For further reading, official Spring Boot documentation, docs.spring.io/spring-boot/docs/current/reference/html/. Getting started guides on the official Spring website, spring.io/guides. 2. Gearing up. Setting up your Spring Boot workshop. Every great craftsperson needs a well-equipped workshop. Whether you're a carpenter, a chef, or a software developer, having the right tools in the right place makes all the difference. For building Spring Boot applications, our workshop includes a few essential components that you'll need to set up on your computer. Don't worry, it's a straightforward process, and with Spring Boot, the initial setup is remarkably quick. The essential tools for your workshop. To build and run Spring Boot applications, you'll primarily need 3 categories of tools. The Java Development Kit, JDK. Your core language tool. This is the absolute fundamental requirement. Think of the JDK as the complete set of blueprints, raw materials, and specialized machinery needed to work with Java. It includes the Java Runtime Environment, JRE. This is what actually runs compiled Java programs. Development tools. Crucially, it provides compilers that turn the Java code you write into instructions your computer can understand, along with debuggers and other utilities vital for development. Recommendation. While there are many versions of Java, it's best to use a long-term support (LTS) version like Java 17 or Java 21. These versions receive extended support and updates, making them stable choices for development. You can download a JDK from various providers like Oracle, Adoptium OpenJDK, or Amazon Corretto. Build tools, your automated factory managers. Once you've written your Java code, you need a way to compile it, manage its external libraries, dependencies, and package it into a runnable application. This is where build tools come in. They automate this entire process, saving you immense time and effort. The two most popular choices in the Java ecosystem are Maven. This is a very widely adopted and mature build tool, often considered the default for many Spring projects. It uses a configuration file named POM.xml, Project Object Model, to define how your project is built and what external libraries it needs. Maven emphasizes convention and provides a structured way to manage your project. Gradle, a more modern and flexible alternative, Gradle uses a more programmatic and customizable approach, often configured with Groovy or Kotlin scripting. Its main configuration file is build Gradle. Gradle is known for its performance and adaptability, making it popular in newer projects. You only need one of these build tools for a given project. We'll mostly discuss the conceptual steps with them being interchangeable, as Spring Boot works seamlessly with both. Integrated Development Environment, IDE, your smart workbench. An IDE is a software application that provides a comprehensive environment for programming. It's much more than just a text editor. It's your central hub for writing code, fixing errors, running your application, and managing your project. IntelliJ IDEA, highly recommended for Spring Boot development. It comes in a free community edition, which is excellent, and a powerful ultimate edition for advanced enterprise features. IntelliJ IDEA offers superb integration with Spring Boot, intelligent code completion, powerful debugging tools, and a very user-friendly experience. Eclipse with Spring Tools 4, another very popular and powerful open-source IDE. With the Spring Tools 4 plugin, Eclipse offers strong support for Spring Boot development. It's also free to download and use. VS Code with Java extensions, a lightweight, fast, and highly customizable code editor. While not a full-fledged IDE out of the box, it can be extended with various plugins, like the language support for Java TM by Red Hat, debugger for Java, etc., to provide an excellent Java development experience. The choice of IDE is largely personal preference, but they all significantly boost productivity by doing things like highlighting syntax errors, suggesting code improvements, and providing built-in ways to run and debug your applications. Using Spring Initializer, your project starter kit, the easiest and most recommended way to kickstart any new Spring Boot project is by using the Spring Initializer. This is a fantastic web-based tool that generates a ready-to-import project structure based on your selections. It ensures that all the necessary files, build configurations, and initial dependencies are correctly set up, so you avoid common pitfalls. Here's a conceptual walkthrough of how you'd use it. Open your web browser, navigate to start.spring.io. This is the home of the Spring Initializer. Choose your project settings, project type. You'll select either Maven Project or Gradle Project, depending on which build tool you prefer. Language, choose Java. Spring Boot version, select a stable version, typically the latest one without snapshot or M for milestone markers, which indicate pre-release versions. Project metadata, this includes identifiers for your project. Group, a unique identifier for your organization or personal projects, e.g., example, your name. Artifact, the name of your specific project, e.g., Myferstab Tatoservice. Name, a display name for your project. Description, a brief explanation of what your project does. Package name, based on your group and artifact, this defines the root package for your Java code, e.g., example Myferstab. Packaging, usually jar for an executable jar file, as discussed in Chapter 1. Java version. Match this to the JDK version you have installed or plan to use. Add dependencies, crucial step. This is where you tell Spring Initializer what kind of features your application will need. These are often referred to as starters. Click the Add Dependencies button. A search box will appear. For almost any web application, you'll want to add Spring Web. This starter brings in everything needed to build web applications. including the embedded web server and tools for handling HTTP requests. For applications that interact with databases, you might add Spring Data JPA for Java Persistence API and a database driver like H2 Database, a lightweight in-memory database excellent for local development and testing, as its data is temporary. As you type, suggestions will appear. Select the ones relevant to your project. Generate and download. Once you've made all your selections, click the Generate button. This will download a zip archive file containing your newly generated Spring Boot project. Import into your IDE. Unzip the downloaded archive to a location on your computer. Open your chosen IDE. Most IDEs have an Open or Import Project option. For IntelliJ IDEA, you can usually select Open and navigate to the unzipped project folder, choosing the POM.xml for Maven or BuildGradle for Gradle file. For Eclipse, you might choose Import, Maven, existing Maven projects, and select the project folder. The IDE will then process the project, download the necessary libraries, and configure itself, understanding the basic project structure conceptually. Once imported, your IDE will display a structured view of your project files and folders. Here's a conceptual overview of the key parts you'll see. src/main/java. This is where you'll write all your core Java application code. It will usually contain a package structure reflecting your group and artifact IDs, e.g., example myfirstapp. Inside, you'll find one main application class, e.g., myFirstAppApplicationJava. This class often has a special annotation that flags it as the starting point for your Spring Boot application. src/main/resources. This directory is for non-Java resources that your application needs. Application.properties or application.yml. This is a crucial file for configuring your application. You'll use it to set things like the web server port, database connection details, or any other application-specific settings. Other subfolders might exist for static web content, like HTML pages or images, or templates for dynamic web pages. src/test/java. This is where you'll write your Java test code. It follows a similar package structure to your main Java code, but is kept separate. POM.xml for Maven or BuildGradle for Gradle. These files are the heart of your build tool configuration. They list all the external libraries, dependencies, your project relies on and define how your project should be compiled, packaged, and run. When you add dependencies through Spring Initializer, they are automatically added here. Your first launch, running an empty Spring Boot application. Now that your workshop is set up, let's run your newly generated, empty Spring Boot application. This is a crucial step to confirm that your JDK, build tool, and IDE are all correctly configured and working together. Locate the main application class. In your IDE, navigate to src/main/java and find the main Java class for your application. It will typically be named after your project, with application appended, e.g., myFirstAppApplicationJava. This class contains a standard main method, just like any other executable Java program. Run the application. Most IDEs provide an easy way to run this class. You can often click on the file in the Project Explorer and select a Run option, e.g., Run myFirstAppApplicationMain. Alternatively, you can click the green Play button or a similar run icon usually found next to the main method definition or in the toolbar. Observe the console output. A console window will typically open within your IDE, displaying the application's output. You should see the Spring Boot banner, a distinctive text-based visual of the Spring Boot logo. Startup messages. Various messages indicating that Spring Boot is initializing, discovering components, and configuring itself. Embedded server status. Importantly, you'll see messages indicating that an embedded web server, usually Tomcat, is starting up and listening for requests on a specific port, most commonly port 8080, e.g., Tomcat started on ports 8080 HTTP with context path. No errors. If everything is set up correctly, you shouldn't see any critical error messages. Congratulations! If you've reached this point, you've successfully set up your Spring Boot workshop and launched your very first, albeit empty, Spring Boot application. It's now listening for requests, ready for you to build upon it. This simple, Hello, world equivalent confirms your environment is healthy and ready for action. In the next chapter, we'll delve into the autopilot features of Spring Boot, understanding the core principles that make it so powerful and efficient before we start building something truly functional. For further reading, download and install Java, OpenJDK, or Oracle. Many online guides are available for your operating system, e.g., search Install JDK on Windows, Mac OS Linux. Maven official website, maven.apache.org/download-CGI. Gradle official website, gradle.org/install/. Spring Initializer website, start.spring.io. IntelliJ IDEA, jetbrains.com/idea/. Eclipse IDE, eclipse.org/download/. VS Code, code.visualstudio.com. 3. The Autopilot Advantage. Understanding Spring Boot's core principles. In our last chapter, we successfully set up our Spring Boot workshop and launched an empty application. You might have noticed how quickly it started and how little configuration we had to do. This just works. Sensation is at the heart of Spring Boot's power, and it comes from some fundamental principles that act like an advanced autopilot system for your application. At its core, Spring Boot dramatically minimizes the amount of manual setup and configuration traditionally associated with Spring applications. It does this mainly through two key mechanisms: auto-configuration and Spring Boot starters. Closely related to these and foundational to the broader Spring framework are the concepts of dependency injection, DI, and inversion of control, IOC, which Spring Boot leverages seamlessly. Auto-configuration, the intelligent assistant. Imagine you're setting up a new home office. Instead of manually buying and connecting every single wire, power strip, and device, imagine an intelligent assistant that looks at your desk. If it sees a printer, it automatically installs the right drivers and connects it to your network. If it sees a monitor, it configures your computer to extend its display. It makes sensible assumptions and handles routine tasks for you, only asking for your input if there's a choice it cannot make on its own. This is fundamentally what Spring Boot's auto-configuration does for your application. What it is. Auto-configuration is Spring Boot's cunning ability to automatically configure your application based on the libraries you've added to your project and the configuration you've already provided. It intelligently inspects your class path, the collection of all the libraries your application can use, and your existing settings. Based on what it finds, it makes smart default configuration decisions. How it works, in simple terms: when your Spring Boot application starts, it performs a series of checks. For example, is the web library present? Yes. Okay, I'll automatically set up an embedded web server for you, like Tomcat, and configure Spring's web handling components. Is a database access library, like JPA, present? Yes, and have you provided custom database connection details? No. Okay, I'll assume you want to use a common default like an in-memory H2 database for development and configure a database connection for you automatically. Is the security library present? Yes, I'll automatically provide some default security settings. Benefits: reduced boilerplate. You don't need to write lengthy XML files or many lines of Java code just to get basic features working. Spring Boot handles it. Faster development. Less time spent on configuration means more time building meaningful features. Sensible defaults. It provides reasonable defaults that work for most common scenarios. Override capability. Crucially, auto-configuration is opinionated, but not restrictive. If Spring Boot's default doesn't fit your needs, you can easily provide your own custom configuration, e.g., in application.properties/applicationML, and your custom settings will always override the auto-configured ones. This gives you ultimate control when you need it. Spring Boot starters, pre-assembled kits. Auto-configuration relies heavily on what libraries you include in your project, but managing these libraries individually can still be complicated. This is where Spring Boot starters come in. What they are: starters are special dependencies, libraries, that simplify your build configuration by providing a set of pre-configured, compatible, and commonly used library groups. They are named in a clear, consistent pattern. Spring Boot starter name. Examples: Spring Boot Starter Web. As we used in Chapter 2, This starter pulls in all the necessary libraries to build web applications, including features for RESTful APIs, the embedded Tomcat web server, and tools for handling JSON data formats. Spring Boot Starter Data JPA. This starter provides everything you need to interact with relational databases using JPA, Java Persistence API, including the popular Hibernate ORM implementation and JDBC, Java Database Connectivity, drivers. Spring Boot Starter Test. This starter provides the libraries for testing Spring Boot applications, including JUnit and Mockito. Benefits: simplified dependency management. Instead of manually adding a dozen individual libraries and worrying about their compatibility, you add just one starter. The starter handles pulling in all the necessary transitive dependencies, the libraries that the starter's primary libraries themselves need, with versions that are known to work well together. Reduced version conflicts. Spring Boot manages the versions of all libraries pulled in by its starters, significantly reducing the common developer headache of dependency hell, where different libraries require conflicting versions of the same underlying component. Improved clarity. The starter names themselves are descriptive, making it clear what functionality adding a particular dependency will provide. Together, auto-configuration and starters form the backbone of Spring Boot's rapid development capabilities. They allow you to add a starter, and Spring Boot automatically configures the components related to that starter, letting you focus immediately on your application's logic. Dependency injection, DI, and inversion of control, IOC. The providing hand. While auto-configuration and starters are Spring Boot innovations, they build upon fundamental principles from the core Spring framework: inversion of control, IOC, and dependency injection, DI. You won't typically configure these directly with Spring Boot. Rather, Spring Boot leverages them behind the scenes to make its magic happen. Inversion of control, IOC, traditional approach. In older programming paradigms, if Object-A needed Object-B to perform its function, Object-A would be responsible for creating Object-B itself. This leads to tightly coupled code, making it hard to change or test individual components. IOC approach. With IOC, the framework in our case, Spring's IOC container, takes over the responsibility of creating, configuring, and managing the lifecycle of your application's objects. Instead of your code calling the framework calls and manages your code. This is called inversion because the control of object creation and management is inverted. It's no longer handled by your objects. Analogy. You're a chef. If you were traditionally in control, every time you needed fresh vegetables, you'd have to go to the market, select them, and bring them back to your kitchen. With IOC, you just tell your intelligent kitchen assistant what vegetables you need, and they appear at your workstation when you're ready. The assistant is in control of providing the ingredients. Dependency injection, DI. This is a specific pattern to implement IOC. It means that an object's dependencies, other objects it needs to perform its function, are injected or provided to it by an external source, the Spring IOC container, rather than the object creating those dependencies itself. Analogy, continuing the chef example. When the kitchen assistant places the vegetables, your dependencies, directly onto your workstation, that's dependency injection. You didn't go fetch them, they were injected into your workspace. In practice, in a Spring Boot application, you'll largely benefit from DI without thinking too much about it. For instance, you might have a user service that needs a user repository to save user data. Instead of user service creating a user repository, you simply declare that user service needs a user repository. Spring Boot's IOC container will automatically instantiate user repository and inject it into user service for you. This is often done using a simple annotation, which we'll see in future chapters, that conceptually tells Spring, "Please provide an instance of this for me." Component scanning. Spring Boot also uses something called a component scan or auto-detection. When your application starts, it scans your project for classes that have specific Spring annotations, like at component, at service, at repository, or at REST controller. When it finds them, it registers them as beans, objects managed by the Spring IOC container, and makes them eligible for dependency injection. This means you rarely have to manually tell Spring Boot about your custom classes. It finds them inherently. By intelligently combining auto-configuration with the power of starters, and building upon the foundational concepts of IOC and DI, Spring Boot effectively handles most of the plumbing and setup for you. This frees you to concentrate on the unique logic and features of your application, accelerating your development journey significantly. In the next chapter, we'll put these concepts into action as we build our very first, simple RESTful API, finally turning our theoretical workshop setup into a functional application. For further reading, official Spring Framework documentation on IOC container. docs.spring.io/spring-framework/current/reference/html/core-html, specifically the section on the IOC container. Spring Boot features documentation on auto-configuration and starters. docs.spring.io/spring-boot/docs/current/reference/html/features-html, sections on auto-configuration and starters. For your first launch, building a simple RESTful API. We've set up our workshop, understood Spring Boot's autopilot capabilities, and now it's time for action. In this chapter, we're going to build our very first functional Spring Boot application, a simple greeting service. This service will act as a basic RESTful API, which is a common way for different software systems to communicate over the web. When someone sends a specific request to our service, it will respond with a friendly message. Project Setup Revisited. Before we begin, remember our discussions in Chapter 2 about using the Spring Initializer. To follow along, ensure you've generated a new project from start.spring.io and, crucially, selected the Spring Web dependency. This starter is what provides all the necessary components for building web applications, including the embedded web server and the tools for handling incoming web requests and sending back responses. The REST controller, your application's listener. In a web application, the part that listens for incoming web requests and decides how to handle them is called a controller. Think of it as the front desk of a hotel. It receives visitors, checks their requests, and directs them to the right place or provides them with the information they need. In Spring Boot, we create a controller by defining a regular Java class and marking it with a special annotation called @RESTController. This annotation is a powerful shortcut provided by Spring Boot. It tells Spring two important things about your class. This class will handle incoming web requests. It recognizes it as a component responsible for receiving messages from web browsers, mobile apps, or other services. Methods in this class will return data directly as the content, or body, of the web response. This means that whatever your method computes or retrieves, Spring Boot will automatically convert it into a format suitable for web communication, like plain text or JSON data, and send it back to the requester. This saves a lot of manual work. So, for our greeting service, we would create a Java class, perhaps named Greeting Controller, and place the @RESTController annotation conceptually at the very top of its definition, handling a simple HTTP GET request with @GET mapping. Web applications use different types of HTTP methods to perform various actions. The most common one is GET. A GET request is typically used to retrieve information from a server. It's like asking a question, "Give me the weather forecast," or "Show me my profile information," to define a specific endpoint. A unique URL path that responds to an HTTP GET request, we use another Spring Boot annotation called @GET mapping. This annotation is placed above a method inside our @RESTController class. The value we provide to @GET mapping is the URL path that, when visited, will trigger that particular method. Let's imagine a method inside our Greeting Controller class, aptly named SayHello. We would conceptually place @GET mapping /hello directly above its definition. This tells Spring Boot, when an HTTP GET request comes in for the path hello, for example, HTTP localhost :8080/hello, execute this SayHello method. The SayHello method itself would be very simple. Its primary job would be to produce a greeting message. Since our greeting controller is annotated with @RESTController, whatever string SayHello returns, such as "Hello, Spring Boot" from the API, will be taken by Spring Boot and sent directly back as the web response, returning JSON data, simplified. While our first example returns simple text, modern web APIs frequently exchange data using JSON, JavaScript Object Notation. JSON is a lightweight, human-readable format for representing structured data. Thanks to the Spring Web Starter, Spring Boot comes with built-in capabilities to handle JSON automatically. If your controller method were to return a regular Java object, for example, a custom class with fields like a message text and a timestamp, Spring Boot would automatically convert that Java object into its equivalent JSON representation for the web response. You wouldn't need to write any manual code for this conversion. Spring Boot takes care of it seamlessly. This auto-conversion is a huge productivity booster. Running your application and testing it. Now that we conceptually have our greeting controller set up, let's run our Spring Boot application and see it in action. Run the main application. Just as we did in Chapter 2, locate the main application class, e.g., My First App Application Java in your IDE. Right-click on it and choose the option to run the application. Observe the startup. Your IDE's console will again display the Spring Boot banner and messages indicating that the embedded web server, usually Tomcat, is starting on its default port 8080. Test in your web browser. Once the console confirms that Tomcat has started on port 8080, open any standard web browser, like Chrome, Firefox, or Edge. In the address bar, type the following address and press Enter. http localhost:8080/hello. What you should see displayed directly in your browser window is the greeting message. Hello, Spring Boot from the API. Test with a command line tool, optional for tech-savvy readers. Many developers use command line tools to interact with web APIs. A very common one is CURL. If you have CURL installed, it comes pre-installed on most Linux and macOS systems and can be installed on Windows. You can open your computer's terminal or command prompt and type curl http localhost:8080/hello. Press Enter and the greeting message, Hello, Spring Boot from the API, will be printed directly in your terminal window. This might seem like a small step, but it's a profound one. You've just successfully built and run a functional web endpoint with Spring Boot serving a web request. Notice how little actual code you had to write and how quickly you got here. This is the core promise and power of Spring Boot, letting you focus on the unique functionality of your application rather than spending time on intricate setup and configuration. In the next chapter, we'll expand upon this foundation, exploring how to make our API more interactive by receiving dynamic information from incoming requests and structuring more complex responses. For further reading, official Spring Web documentation, docs.spring.io/spring-framework/docs/current/spring-framework-reference/webhtml. Basic concepts of RESTful API design, a general computer science topic with many online tutorials available. 5. Interacting with the world, handling requests and responses. In our last chapter, we successfully created a simple greeting service that responded with a fixed message when we visited a specific web address. That was a great start, but real-world applications need to be much more dynamic. They need to receive different kinds of input from users or other systems, process that input, and provide tailored responses. This chapter delves into how Spring Boot allows your application to interact more deeply with the world by extracting information from incoming web requests and crafting more sophisticated responses. We'll explore how to get data from the web address itself, from the optional pieces of a web address, and from the more structured package of data sent with certain requests. Expanding on REST controller and request mapping. As a quick refresher, the @REST controller annotation marks a Java class as a web controller in Spring Boot, handling incoming web requests and directly returning data as the response. We used @get mapping in the previous chapter, which is a specialized version of the older, more general @request mapping annotation. While @request mapping can be used for any HTTP method, get, post, put, delete, etc., and can be placed at both the class level to define a base path for all methods in the controller, like /API/v1/products, and the method level @getMapping, and its siblings like at post mapping, at put mapping, at delete mapping, are more specific and often preferred for clarity. They indicate that the method will only respond to a particular HTTP method. Let's imagine we're building a simple to-do list application, which will serve as our running example for this and future chapters. Handling path variables, data from the URL path at path variable. Sometimes, the information you need is embedded directly within the web address itself. This is common when you want to identify a specific resource. For example, if you want to retrieve a to-do item with a particular ID, the ID might be part of the address, like /todos/123. The number 123 here is a path variable. Concept: the @path variable annotation allows your Spring Boot controller methods to extract these dynamic values directly from the Uniform Resource Locator, URL, path. Conceptual example: to retrieve a single to-do item by its ID, your controller method would be structured to capture that ID from the URL. Imagine a method called getToDoById. Above this method, you would conceptually place at getMapping /todos/id. The curly braces id act as a placeholder. This tells Spring that whatever value appears in that position in the URL should be treated as a variable. Inside the method's definition, you would have a parameter like long_todoId marked with @path variable. Spring Boot automatically takes the value from the id placeholder in the URL, e.g., 123 from /todos/123, and injects it into your TodoId method parameter. You can then use this TodoId variable within your method to look up and retrieve the correct to-do item from your data storage. Handling request parameters, filtering and options at request param. Other times, you need to provide optional information or filter criteria that doesn't identify a specific resource, but rather modifies a search or provides additional options. This kind of information is typically placed in the query string portion of a URL, which comes after a question mark. For example, /todos, completed equals false and sort by equals due date. Here, completed and sort by are request parameters. Concept: the @request param annotation allows you to extract values from this query string. Conceptual example: to search for to-do items, you might want to filter them by their completion status or sort them. Your controller method might look like this. Imagine a method called searchTodos. It would conceptually be mapped to getMapping /todos. Inside its method definition, you might have parameters like Boolean completed and string sort by, both marked with @request param. If someone visits /todos, completed equals true, the completed parameter in your method would receive the value true. If they visit /todos, search equals bymulk, the search parameter would get bymulk. You can also mark parameters as optional, e.g., required equals false, if they don't always need to be present in the URL. Working with request bodies, sending data to the server at request body. The HTTP GAT method, as we've seen, is primarily for retrieving data. But what about when you want to send data to the server, like when you're creating a new to-do item or fully updating an existing one? For these operations, you typically use HTTP methods like POST for creating new resources or PUT for updating existing resources. When you use POST or PUT, the data you're sending to the server is placed in the body of the HTTP request, similar to how an email has a body. This data is often in JSON format because it's widely adopted for structured data exchange on the web. Concept: the @request body annotation tells Spring Boot to read the contents of the HTTP request body and automatically convert it into a Java object for you. Conceptual example: to create a new to-do item, your controller method would be configured to accept a POST request and read the incoming data. Imagine a method named createToDo mapped to @post mapping /todos. Inside its parameter list, you would have an argument, for example, to-do item new to-do, marked with @request body. To-do item would be a simple Java class representing the structure of a to-do item, e.g., containing fields for a title, description, and completion status. When a client sends a POST request to /todos with a JSON body resembling title, buy groceries, description, milk, bread, eggs, completed. False, Spring Boot, thanks to the libraries included with the Spring Web Starter, automatically takes that JSON string and turns it into an actual to-do item Java object. You can then work with this Java object directly in your method. A similar approach applies to updating a to-do item using @put mapping. HTTP status codes and error handling. Communicating outcomes. When your application responds to a request, it doesn't just send data, it also sends an HTTP status code. This numerical code provides crucial information about the outcome of the request. Think of it as a signal to the client. 200 OK, this is the universal, everything went well code. 201 created, used specifically when a new resource has been successfully created, common for post requests. 204 no content, indicates that the request was successful, but there's no content to return, often used for delete requests. 400 bad request. The client sent data that was somehow malformed or invalid relative to what the server expects. 404 not found. The requested resource, e.g., a to-do item with a specific ID, does not exist. 401 unauthorized/403 forbidden pertains to security. Unauthorized means you need to log in. Forbidden means you are logged in but don't have permission for that action. 500 internal server error. A general-purpose error indicating something went wrong on the server's side itself. Spring Boot automatically sets appropriate status codes for successful operations. For errors, it provides a default error page or a default JSON error response. For more control, developers can implement custom error handling to return specific error messages and codes, making their APIs more robust and user-friendly for other systems consuming them. Building a more robust to-do list API. Let's bring these concepts together by envisioning how our to-do list application's API would look. Get to-dos. Retrieve a list of all to-do items. Uses @get mapping without any path variables or request parameters for a simple list, or with @request param for filtering sorting. Get/todos/ID. Retrieve a single to-do item by its unique ID. Uses @get mapping with @path variable. Post/todos. Create a new to-do item. The new item's details, e.g., title, description, would be sent in the request body as JSON. Uses @post mapping with @request body. PUT/todos/ID. Update an existing to-do item. The updated details would be sent in the request body as JSON, and the id would specify which item to update. Uses @put mapping with @path variable and @request body. Delete/todos/ID. Remove a to-do item. Uses @delete mapping with @path variable. Notice how these operations map directly to the fundamental actions you perform with data. CRUD, create, read, update, delete. By leveraging @path variable, @request param, and @request body, along with the various HTTP methods and status codes, your Spring Boot applications can become highly interactive, capable of receiving complex instructions and data from the world and responding with precision. This forms the foundation for building powerful and flexible web services. In the next chapter, we'll continue to build out our to-do list application by adding the capability to store our to-do items permanently using a database. For further reading, official Spring web reference on request mapping. docs.spring.io/spring-framework/docs/current/spring-framework-reference/web-html #web-template-variables and web-html #web-bind-request parameters. MDN web docs on HTTP status codes. developer.mozilla.org/n-us/docs/web/http/status. Introduction to JSON, json.org, for understanding the format data is often exchanged in. 6. Storing your story, integrating databases. So far, our to-do list application is quite impressive in its ability to handle web requests and produce responses. However, there's a big problem. If you were to shut down the application and start it again, all your carefully added to-do items would disappear. This is because any data we've been working with so far only resides in the computer's temporary memory while the application is running. For data to outlive your application's runtime, it needs to be stored persistently. This is where databases come in. A database is an organized collection of structured information, or data, typically stored electronically in a computer system. It's designed to allow efficient storage, retrieval, modification, and deletion of large amounts of information. Why databases are essential. The need for persistence. Imagine your to-do list application as a whiteboard. You can write tasks on it, erase them, or mark them as complete. But as soon as you wipe the board clean or shut down the application, all that information is lost. A database provides a permanent, searchable, and structured way to store your story. Your to-do items, user profiles, product catalogs, or any other critical information an application needs to remember. There are many types of databases, but for general purposes, they often fall into two main categories. Relational databases, SQL. These are the most traditional and widely used databases. They store data in tables, which are organized into rows and columns, much like a spreadsheet. Relationships between different pieces of data are defined through common columns, keys. They use SQL, structured query language, for interacting with the data. Examples include MySQL, PostgreSQL, Oracle, SQL Server, and the lightweight H2 database we'll use for development. NoSQL databases. These are a newer class of databases designed for flexibility, scalability, and performance, especially with large, unstructured, or semi-structured data. They offer various data models like key value, document, column family, and graph. Examples include MongoDB, Cassandra, and Redis. For our to-do list, we will focus on relational databases, as they are a very common choice for many business applications, and Spring Boot has excellent support for them. Bridging objects and tables, JPA and ORM. Our Spring Boot application works with Java objects, like our to-do item class, but relational databases store data in tables. How do we translate between the world of Java objects and database tables? This is where JPA, Java Persistence API, and ORM, Object Relational Mapping, come into play. JPA. This is a specification, a set of rules and guidelines in the Java world for managing data persistence. It defines how Java objects can be persistently stored in a relational database. It's like the blueprint for a language translator. ORM. This is the actual language translator, or technique tool, that implements the JPA specification. An ORM allows developers to interact with a relational database using object-oriented concepts, Java objects and methods, rather than writing raw SQL queries. Hibernate is by far the most popular and widely used ORM framework that implements JPA. Benefits. Using an ORM like Hibernate via JPA significantly reduces the amount of repetitive SQL code you have to write. You can work with your familiar Java objects, and the ORM handles translating your object operations, like saving an object, finding an object by its ID, etc., into the appropriate SQL commands for the database. This boosts developer productivity and reduces errors. Connecting to an in-memory database, H2, for development. For development and testing, manually setting up a full-blown database like MySQL or PostgreSQL can be time-consuming. This is why H2 database is an excellent choice for local Spring Boot development. Why H2? Lightweight. It's a very small database that can run entirely within your application's Java process. In-memory mode. It can operate purely in memory, meaning it requires no installation. The database starts automatically when your application starts and exists only as long as your application is running. All data is lost when the application shuts down, which is perfectly fine for development and testing cycles. Easy setup. You simply add its dependency, and Spring Boot's auto-configuration handles much of the rest. Web console. H2 comes with a built-in web-based console, allowing you to visually inspect the database tables and data during development. Setting it up. To use H2 with JPA, you would add two key dependencies, starters, to your project's build file, e.g., POM.xml for Maven. Spring Boot Starter Data JPA. This starter brings in all the necessary components for JPA, including Hibernate and JDBC. H2. This is the H2 database driver itself. In your application.properties or application.yaml file, you might add some configuration for H2. Tell Spring to use an in-memory database. Spring data source URL equals JDBC, H2 mem testdb. Optionally, enable the H2 web console for inspection, only for development. Spring.h2.console enabled equals true. Spring.h2.console path equals /h2 console. You can then access it at http localhost:8080/h2-console once your app is running. Defining your data at entity and at id. To tell JPA and Hibernate that a Java class should be mapped to a database table, we use annotations. At entity, this annotation is placed directly above your Java class, your to-do item class, for example. It signals to JPA that instances of this class represent rows in a database table. By default, the table name will be derived from the class name, e.g., to-do item would map to a totem table. At id, every database table needs a primary key, a column whose values uniquely identify each row. In your Java at entity class, one field must be designated as the primary key using the at id annotation. It's very common to use at generated value alongside at id to instruct the database to automatically generate unique ID values for new entries, so you don't have to manage them manually. So, your to-do item Java class would conceptually have at entity at the top, and at id, and perhaps at generated value on its id field. Other fields like title, description, and completed would map directly to columns in the totem table. Simplified data access. Spring Data JPA and JPA repository. Working directly with JPA or Hibernate, while powerful, can still involve writing some repetitive code for common operations like saving, finding, or deleting data. This is where Spring Data JPA comes to the rescue. Spring Data JPA. This is another highly productive project within the Spring ecosystem. It provides an even higher level of abstraction on top of JPA, allowing you to define powerful data access methods simply by declaring interfaces. JPA repository. This is a core interface provided by Spring Data JPA. Magically, by simply extending this interface in your own Java interface, you gain a vast set of common database operations automatically, without writing any implementation code yourself. How it works: you define a simple Java interface, for instance, to-do item repository. This interface extends JPA repository, specifying two type parameters: the type of entity it manages, e.g., to-do item, the data type of that entity's primary key, e.g., long. So, your interface would look conceptually like: interface to-do item repository extends JPA repository to-do item, long. When your application starts, Spring Data JPA automatically inspects this interface and generates a concrete implementation for you behind the scenes. This generated implementation already provides essential methods like save to-do item to save a new to-do item or update an existing one, find by ID, long id, to retrieve a to-do item by its unique ID, find all, to retrieve all to-do items, delete by ID, long id, to delete a to-do item by its ID. You can even define custom query methods in this interface simply by following specific naming conventions, e.g., find by completed true, would automatically generate a method to find all completed to-do items, connecting our controller to the database, performing CRUD operations. Now we can tie everything together. Our web controller, from Chapter 5, which handles incoming requests, can now use our to-do item repository to interact with the database. Dependency injection in action. Our controller that handles post requests for creating a new to-do item will need access to the to-do item repository. Thanks to Spring's dependency injection, we simply declare that our controller needs an instance of to-do item repository. Spring will automatically create and provide it. Create post request. When a post request to /todos comes in, the controller receives the JSON data, converts it into a to-do item object using @request_body. Then it simply calls to-do item repository save, new to-do item. Spring Data JPA handles the SQL insertion. Read get requests. For get/todos all items, the controller calls to-do item repository find all. The list of to-do item objects is then automatically converted to JSON for the response. For get/todos/ad, single item, the controller calls to-do item repository find by ID. If found, the to-do item is returned as JSON. If not found, the controller can respond with a 404 not found status. Update PUT request. For PUT/todos/AD, the controller receives the updated to-do item data. It first uses findById to retrieve the original item from the database, updates its properties from the incoming data, and then calls to-do item repository save, updated to-do item again. If the ID exists, it updates. If it's a new ID, it effectively creates. Delete request. For delete/todos/AD, the controller simply calls to-do item repository.delete by ID. The remarkable aspect here is how little database-specific code, raw SQL queries, you needed to write. Spring Boot, JPA, and Spring Data JPA collaborate to provide a powerful, high-level abstraction that dramatically simplifies data persistence, allowing you to focus on your application's business logic. With persistence added, our to-do list application can now truly fulfill its purpose. Remember our tasks even after the application restarts. In the next chapter, we'll look at how to tailor our application's behavior to different environments, like development, testing, or production, using configuration and profiles. For further reading, Spring Data JPA documentation, docs.spring.io/spring-data/jpa/current/reference/html/h2 database website, h2database.com, for details on this lightweight development database. Introduction to SQL and Relational Databases. Many online tutorials and courses are available for understanding the basics of SQL. 7. Tailoring your app. Configuration, profiles, and properties. Our to-do list application can now store data persistently. This brings us closer to a real-world application, but a crucial question remains. How does our application adapt to different environments? For instance, the database connection details for your development machine are vastly different from those needed for a production server. An API key for an external service might vary between your testing environment and the live system. Coding these values directly into your application is a major problem, as it would require you to recompile and redeploy your application every time a setting changes. This is where externalized configuration becomes vital. It allows you to keep changeable values outside your main application code, making your application flexible and adaptable without requiring code modifications or recompilation. Spring Boot is a master at handling configuration, providing a robust and flexible system for managing these settings. Externalizing configuration, the need for flexibility. Imagine you run a chain of coffee shops. Each shop needs to know its unique ID, its address, and perhaps the local supplier's contact information. You wouldn't print this information directly onto the coffee machine's internal circuit board. Instead, you'd have a little plate or a configuration manual specific to that shop. If the address changes, you just update the plate, not replace the entire machine. Similarly, an application settings can change based on its environment. Development uses an in-memory database, like H2, runs on localhost. Testing connects to a dedicated test database, perhaps with specific test user credentials. Production connects to a highly available, secure production database, might need specific server ports, and should have debugging features turned off. Externalizing configuration means these values are read at runtime, adapting the application to its current surroundings. Application.properties and application.yml, your primary settings files. The most common and intuitive places to define configuration for your Spring Boot application are application.properties or application.yml files. These files are typically located in the src/main/resources folder of your project. Spring Boot automatically loads these files when your application starts. Application.properties. This file uses a simple key equals value format with each setting on a new line. Example, server port equals 8081. Spring data source URL equals JDBC, H2 mem devdb. My app welcome message equals hello from the configured application. It's straightforward and easy to read for simple configurations. Application.yml, YAML format. YAML ain't markup language, offers a more structured, hierarchical format based on indentation. It's often preferred for readability, especially when dealing with complex or nested configurations. Example, equivalent to the above properties. Server, port, 8081. Spring data source, URL. JDBC H2 mem devdb. My app, welcome, message, hello from the configured application. Important, YAML is sensitive to whitespace. Use spaces, not tabs, for indentation and be consistent. Which to choose? Both work perfectly fine. Many developers prefer YAML for its readability with complex configurations. It's generally a good practice to pick one format for your project and stick to it for consistency. Accessing configuration values. Plugging settings into your code at value. Once you've defined properties in application.properties or application.yaml, you need a way to use them within your Java code. Spring Boot provides a simple way to inject these values directly into your Spring-managed components, like services, controllers, or other components. You use the @value annotation on a field within your class. For example, if you defined myAppWelcome message equals hello from the configured application, in your properties file, you can access it like this. Conceptual example, not actual code. Inside a Spring-managed component, e.g., a controller or service, public class myService, Spring Boot will automatically inject the value of myAppWelcome message here. Private string welcome message, annotated with @value, $myAppWelcome message, public string getGreeting, return welcome message. When your application starts, Spring Boot looks at the myAppWelcome message key in your configuration files and assigns its value to the welcome message field. Spring Profiles, environment-specific settings. While application.properties gives us external configuration, what if you need radically different settings for development, testing, and production environments? This is where Spring Profiles shine. Concept. Spring Profiles provide a way to separate and activate different configuration settings and even different components or beans based on the current environment. You can define various sets of configurations, and only the set corresponding to the active profile will be loaded. How to define profile-specific files. You create separate configuration files named Application Profile Name, Properties, or Application Profile Name, IML. Application.properties contains default settings that apply to all profiles unless overridden. Application-dev.properties, settings specific to the development profile. Application-prod.properties, settings specific to the production profile. Example for our to-do list database. Application-dev.properties. Spring data source URL equals JDBC. H2 mem devdb. db close delay equals 1. db close yongset equals false. In memory H2 db. Spring.jpa hibernate ddl auto equals update. Allow Hibernate to update schema. Application-prod.properties. Spring data source URL equals JDBC. MySQL /prod-server.com:3306/prodtotodb. Spring.datasource.username equals producer. Spring data source password equals secure password. Spring.jpa hibernate ddl auto equals none. Don't allow Hibernate to change schema in prod. When the dev profile is active, your application will use the H2 database. When the prod profile is active, it will connect to the MySQL database. Configuration properties in a profile-specific file override those in the default application.properties file when that profile is active. How to activate a profile. You tell Spring Boot which profile or profiles to activate when starting your application. Command line argument. This is one of the most common ways, especially when deploying. Java jar your app jar -- spring dot profiles active equals prod. Environment variable. For deployment environments, like Docker containers or cloud platforms, export Spring Profiles active equals prod before running Java jar. In application.properties for default development. Spring.profiles active equals dev. This sets a default profile, which can still be overridden by command line arguments or environment variables. Precedence, who wins? Spring Boot loads configuration from a specific order of sources, and later sources can override values from earlier ones. This hierarchy provides extreme flexibility. The rough order of precedence is command line arguments, highest precedence, environment variables, application properties YAML files, profile specific then default. and others down to default values. This means you can have a default value in application.properties, override it for the prod profile, then override that with an environment variable set in your Docker container, and finally override that with a command line argument when you launch the container. This layering ensures you have precise control over your application settings in any deployment scenario. Through its powerful configuration system and the strategic use of profiles, Spring Boot allows you to build a single application artifact that can seamlessly adapt its behavior and connect to different resources based on the environment it's running in. This flexibility is indispensable for developing and deploying modern, resilient applications. In the next chapter, we'll dive into a topic that ensures our application is not just functional and adaptable, but also robust and reliable. Testing. For further reading, Spring Boot externalized configuration documentation. docs.spring.io/spring-boot/current/reference/html/features-html #features-external-config. Official YAML language specification. YAML.org for understanding the syntax. 8. Fortifying your foundation. Essential testing for reliability. We've built our to-do list application, complete with a web API and database persistence. It seems to work well when we interact with it in development. But how can we be truly confident that it always works as expected, especially as we add new features or modify existing ones? This is where testing comes in. Testing is not just an optional extra, it's an indispensable part of modern software development. It's the process of verifying that your code behaves correctly and meets the requirements. For Spring Boot applications, a good testing strategy fortifies your foundation, making your applications more robust, reliable, and maintainable. The importance of testing. Consider a bridge builder. They wouldn't just assemble a bridge and hope it stands. They'd rigorously test the materials, the individual sections, and finally the entire structure under various loads. Software is no different. Early bug detection. Catching bugs during development is significantly cheaper and easier to fix than discovering them in production, where they can cause outages, data corruption, or frustrated users. Ensures correctness. Tests confirm that your application's logic is sound and that it behaves exactly as intended, fulfilling its purpose. Facilitates refactoring and evolution. When you have a comprehensive suite of automated tests, you gain a safety net. You can confidently refactor code, restructure it without changing external behavior, or add new features, knowing that if you inadvertently break something, your tests will quickly tell you. Acts as documentation. A well-written set of tests can serve as clear, executable documentation, illustrating how different parts of your code are expected to be used and how they should behave. Types of testing for Spring Boot applications. There are various levels and types of tests, each serving a distinct purpose. For a Spring Boot application, the most common and essential types are unit testing and integration testing. Unit testing, focusing on the smallest parts. Concept. Unit tests focus on verifying the smallest testable parts of your application in isolation. A unit is typically a single method, a class, or a small, self-contained component. Focus. The goal is to ensure that the internal logic of these individual units is correct, independent of other parts of the application or external systems. This means deliberately isolating the unit under test from its dependencies by using mocks or test doubles. How Spring Boot helps or doesn't interfere. For true unit tests, you often don't need the full Spring Boot application context loaded. You can use standard Java testing frameworks like JUnit 5 and mocking libraries like Mockito. Mockito allows you to create mock versions of dependent objects, letting you control their behavior during the test and verify that your unit interacts with them correctly. Conceptual example. Imagine we have a to-do service class with a method mark as completed, long to-do ID. This method should look up the to-do item in a repository, update its status, and save it back. In a unit test for this method, you would arrange. Create a mock to-do repository using Mockito. Define what the mock should return when findById is called e.g., a specific to-do item. Act. Call to-do service mark as completed 123L. Assert. Verify that to-do item is completed. is now true, and crucially, verify that the to-do repository save method was called exactly once with the updated to-do item. You are only testing the mark has completed logic, not the actual database interaction. Integration testing, ensuring components work together. Concept: integration tests verify how different components or layers of your application interact and work together as a cohesive system. These tests involve more of the application's context, often including Spring Boot's dependency injection and auto-configuration. Focus: these tests ensure that the various parts of your application, e.g., your web controller, service layer, and data repository, correctly communicate with each other, that data flows as expected, and that the system as a whole behaves correctly when integrated. Integration tests are typically slower than unit tests because they involve more of the system. How Spring Boot helps. Spring Boot provides specialized testing annotations that can automatically configure and load a partial or full application context, making integration testing much simpler and more focused. At Spring Boot Test, this is the most comprehensive integration test annotation. It loads the entire Spring Boot application context. It's useful for end-to-end tests where you need almost everything wired up, perhaps even starting a real embedded web server and connecting to a test database. This is usually the slowest type of test. At Web MVC Test, this annotation focuses specifically on testing Spring MVC components, particularly your web controllers. It auto-configures the Spring MVC infrastructure, but excludes other parts of your application, like the service and database layers. This makes it faster and more focused for testing REST endpoints. You would typically use mocking for service and repository layers within these tests. At Data JPA Test, this annotation is designed for testing your Spring Data JPA repositories and database interactions. It configures an in-memory database, like H2, allowing you to test your repository methods directly against a real, though temporary, database without affecting your main application database. It only loads the necessary JPA components, keeping the test focused and fast. Conceptual example, at Web MVC Test, imagine testing our to-do controller's endpoint to create a new to-do item, post to-dos. In this test, you would arrange, mock your to-do service, since at Web MVC Test doesn't load the full service layer. Define what the mock to-do service should return when its create-to-do method is called. Act. Simulate an HTTP post request to /todos using a test helper provided by Spring, e.g., mock MVC, sending a JSON payload representing a new to-do item. Assert. Assert that the HTTP response has the correct status code, e.g., 201 created, that the response body contains the expected JSON representation of the created to-do item, and that your mock to-do service create-to-do method was called correctly. Conceptual example at Data JPA Test. To test your to-do item repository's functionality, you would arrange, create a to-do item object. Act. Save the to-do item using to-do item repository save, to-do item. Then, retrieve it using to-do item repository find by ID, to-do item get ID. Assert. Assert that the retrieved to-do item matches the one you saved, e.g., its title and description are correct. This confirms that your database interaction logic works as expected. General structure of a test. Regardless of the type, most automated tests follow a common structure, often called arrange act assert or given when then. Arrange given. Set up the necessary prerequisites, initial conditions, or mock objects. This prepares the world for your test scenario. Act when. Execute the specific code or method you want to test. This is the action you are performing. Assert then. Use special assertion methods provided by JUnit or other assertion libraries to verify the outcome. This confirms that the actual result matches your expected result. For example, assert equals expected value, actual value, assert true condition, or assert not null object. By diligently writing unit tests and integration tests, you are building a safety net around your application. This netting allows you to iterate faster, refactor with confidence, and ultimately deliver a more reliable and higher quality product. In the next chapter, we'll move beyond development and discuss how to package and deploy our Spring Boot application, making it ready for the real world. For further reading, Spring Boot testing documentation, docs.spring.io/spring-boot/docs/current/reference/html/features testing. JUnit 5 documentation, junit.org/junit5/docs/current/user-guide/ the standard for Java unit testing. Mockito documentation, site.mockito.org, for learning about mocking objects in tests. 9. Deployment day, packaging and running your applications. We've explored how to build a robust to-do list application, how to make it adaptable through configuration and profiles, and how to ensure its reliability with testing. Now comes a crucial step, taking our application from our development environment and making it available for others to use. This is deployment day. One of Spring Boot's most compelling features is how it simplifies this process. While application deployment used to be a complex, multi-stage affair involving various servers and configurations, Spring Boot streamlines it significantly, especially through its concept of the executable jar. Packaging your application, the executable jar file. At the heart of Spring Boot's simplified deployment is the executable jar file. Jar, Java archive, is a standard format for bundling Java classes and associated metadata. However, a Spring Boot executable jar is quite special. It's often referred to as a fat jar or uber jar because it contains everything needed to run your application within a single, self-contained file. This single file includes all your compiled application code, all the third-party libraries, dependencies that your application relies on, crucially, an embedded web server like Apache Tomcat, Jetty, or Undertow. The benefit: this all-in-one packaging approach means you no longer need to install or configure an external web server or application server separately. Your Spring Boot application is truly self-sufficient. You just run this single jar file, and it starts its own web server and serves your application. How to build, conceptually. Creating this executable jar is handled seamlessly by the build tools we discussed in Chapter 2, Maven or Gradle, thanks to the Spring Boot Maven plugin or Spring Boot Gradle plugin. These plugins are typically included by default when you generate a project using Spring Initializer. With Maven, you would open your terminal or command prompt, navigate to your project's root directory, where the pom.xml file is located, and simply type mvn package. With Gradle, similarly from your project's root directory, where the build Gradle file is located, you would type Gradle bootjar. After running one of these commands, your build tool will compile your code, download all necessary dependencies, run your tests, and then bundle everything into a single jar file. This file will typically be found in a target directory for Maven or build libs directory for Gradle within your project folder. The file name will usually be something like your application name jar. The role of the embedded server, your application's built-in engine. The concept of an embedded server is a game changer for Spring Boot applications. When you package your application as an executable jar, an instance of a web server, by default, Apache Tomcat for web applications, is directly included within that jar file. How it works. When you execute the jar, the embedded server starts up within the same Java Virtual Machine, JVM, process as your application. It then automatically configures itself to listen for incoming web requests on a specified port, default 8080, or as configured in application.properties/iml. Why it's revolutionary. Simplicity. No more external server installations, configurations, or separate deployment steps. Portability. Your application can be easily moved and run on any system that has a compatible Java runtime environment, JRE, installed without worrying about system-specific server setups. Isolation. Each application runs with its own dedicated server, avoiding conflicts that can arise when multiple applications share a single, externally managed server. Running the executable jar file. One simple command. This is the moment of truth, where all our work comes together. Once you have the executable jar file, running your application is incredibly straightforward. Open your terminal or command prompt. Navigate to the directory where your executable jar file is located. Type the following command and press enter. Java jar your application name jar. You will see console output, very similar to when you ran the application from your IDE. The Spring Boot banner, various startup messages, and confirmation that the embedded server has started and is listening on its designated port. Your application is now live and ready to serve requests. Basic deployment considerations. Where your app goes live, the self-contained nature of Spring Boot executable jars makes them ideal for modern deployment environments. Cloud platforms. Spring Boot applications are perfectly suited for deployment to various cloud computing services. Platform as a Service, PaaS. Services like Heroku, Cloud Foundry, or Google App Engine allow you to simply upload your jar file. The platform handles the underlying infrastructure, scaling, and operational concerns. Infrastructure as a Service, IaaS. You can deploy your jar onto a virtual machine, e.g., AWS EC2, Azure VMS, Google Cloud Compute Engine. You manage the operating system and then simply run your Java jar command. Containerization, Docker, and Kubernetes. This has become a dominant deployment strategy. Docker packages your application and all its dependencies into a lightweight, portable container. Since Spring Boot applications are already self-contained jars, they fit perfectly into Docker containers. Kubernetes then orchestrates these containers across a cluster of machines for scalability and resilience. This approach guarantees that your application runs identically regardless of the environment. Traditional servers. WAR files a brief note. While the executable jar with an embedded server is the modern and preferred approach for most new Spring Boot applications, Spring Boot can still be configured to produce a WAR web application archive. File. WAR files are designed to be deployed onto traditional, externally managed application servers, like an existing Tomcat installation, that expect to host multiple web applications. However, for simplicity and alignment with cloud-native principles, the executable jar is generally recommended. Case study. From local machine to cloud in minutes. Let's imagine our to-do list application is a crucial internal tool for a small team. Development iteration. A developer works on their local machine. They might use the H2 in-memory database and run the application directly from their IDE for rapid feedback. Ready for deployment. Once features are complete and tests pass, they use MVN package or Gradle boot jar to create the executable jar. This jar now contains all the application logic, the Spring Boot Starter Web for web features, Spring Boot Starter Data JPA for database access, and the embedded Tomcat server. Cloud rollout. They then upload the single jar file to a cloud provider's virtual machine. Launch and configure. On the cloud server, they simply execute Java jar to-do list app jar. Crucially, for production, they don't rebuild the jar. Instead, they leverage externalized configuration, Chapter 7, by setting environment variables on the cloud server. For example, sbringdatasourcurl and sbringdatasourcurcrname would be set to point to a robust, separate production database, like PostgreSQL or MySQL, rather than the local H2. Instant access. Employees can now access the to-do list application through a public web address provided by the cloud service. This streamlined process, driven by Spring Boot's executable jar and intelligent configuration, allows teams to deploy new features and updates with unprecedented speed and agility, drastically reducing the time it takes to get innovations into the hands of users. In our final chapters, we'll look at how to monitor your application once it's deployed and what lies beyond the basics of Spring Boot. For further reading, Spring Boot Build Tool Plugins, Maven/Gradle, docs.spring.io/spring-boot/docs/current/reference/html/build-tool-plugins, HTML. Packaging an executable jar. docs.spring.io/spring-boot/docs/current/reference/html/executable-jar-format Introduction to Docker and Containerization. A vast topic, but many introductory resources are available online. 10. The Production Pulse. Monitoring with Spring Boot Actuator. You've built your to-do list application, thoroughly tested it, and successfully packaged and deployed it. It's now running happily in a production environment, serving users. But how do you know if it continues to run happily? How do you detect if it's experiencing performance bottlenecks, running low on resources, or if a critical part of your system, like the database connection, has failed? This is where monitoring comes in, and Spring Boot provides an incredibly powerful and convenient tool for it. Spring Boot Actuator. What is Spring Boot Actuator? Your application's health monitor. Think of Spring Boot Actuator as a comprehensive, built-in diagnostic and reporting system for your application. It provides production-ready features that allow you to monitor, inspect, and manage your running application. It's like giving your application a direct pulse, temperature check, and a window into its internal workings, all exposed through easy-to-use web endpoints, URLs, or Java Management Extensions, JMX, for programmatic access. The core idea is to give you insight into your application as it runs, without requiring you to write mountains of custom monitoring code. It helps answer critical questions like, is my application healthy and responsive? How much memory is it using? Are there any slow web requests? What version of the application is currently deployed? Is my database connection working? Actuator endpoints. Diagnostic windows into your app. To use Actuator, you simply need to add the Spring Boot Starter Actuator dependency to your project's build file. Once included, Spring Boot automatically configures and exposes various endpoints, specific URLs that provide different categories of operational information. Here's a conceptual overview of some of the most common and useful Actuator endpoints and what they reveal. Actuator Health. This is perhaps the most important endpoint for basic monitoring. It provides a summary of your application's health status. By default, it checks things like disk space, database connectivity, and messaging queue connections. If any of these are down, the health check will report a down status. Otherwise, it's UP. Many monitoring systems automatically ping this endpoint to ensure your application is alive and well. You can also customize it to report on various aspects of your application's health. Actuator Info. This endpoint displays general application information. You can configure it to show details like the application's version number, build details, e.g., when it was built, by whom, or any custom information you want to expose, e.g., a welcome message or a specific feature flag status. This is very useful for confirming which version of your application is currently running. Actuator Metrics. This is a goldmine for performance monitoring. It provides detailed metrics about your application's performance and resource usage. This can include CPU usage and memory utilization, heap and non-heap memory. Garbage collection statistics. HTTP request counts and timings, how many requests, how long they took, error rates. Counts of database calls and their latencies. You can even add your own custom business metrics, e.g., number of to-do items created per minute. These metrics can then be integrated with external monitoring systems, like Prometheus or Grafana, to create dashboards and alerts. Actuator Env. This endpoint shows the application's environment properties. This can include system properties, environment variables, and all the configuration values loaded from your application.properties/applicationiml files. Those sensitive values are censored by default. Extremely useful for debugging configuration issues in a live environment. Actuator Beans lists all the Spring beans, the objects managed by the Spring IOC container in your application's context, showing their types and dependencies, helpful for understanding the structure of your running application. Actuator Loggers allows you to inspect and even change the logging levels of different parts of your application at runtime. This is incredibly useful for turning on verbose debugging logs for a specific component, e.g., your database interaction layer, to diagnose an issue in a production environment, and then turning them off again, all without restarting the application. How to access. Typically, Actuator endpoints are exposed under a base URL like http localhost:8080/actuator or http localhost:8080/management if customized. You then append the specific endpoint name, e.g., http localhost:8080/actuator/health or http localhost:8080/actuator/metrics. Most of these endpoints return data in JSON format, making them easy for other systems to consume. Customizing and securing Actuator endpoints. By default, not all Actuator endpoints are exposed over HTTP for security reasons. You can configure which endpoints are enabled and exposed via your application.properties or application.yaml file. For example, to expose the info and health endpoints via HTTP, you would specify management.endpoints.web.exposure. Include equals info, health. Critical security consideration. Actuator endpoints expose sensitive operational and internal application information. You must never expose all Actuator endpoints. Management.endpoints.web.exposure. Include equals directly to the public internet without proper authentication and authorization. Doing so is a significant security risk, as it could reveal sensitive configuration details, allow remote logging level changes, or even trigger shutdowns of your application. Actuator integrates seamlessly with Spring Security, which we'll briefly mention in the next chapter, allowing you to easily secure these endpoints by requiring users to authenticate, e.g., with a username and password, and ensuring only specific roles or users can access them. This is paramount for protecting your application's internal data and operational controls. Analogy: the dashboard of your application's health. Think of Spring Boot Actuator as the sophisticated dashboard in a modern car. It continuously displays vital information like the engine temperature, health, fuel level metrics, tire pressure, and various warning lights and diagnostic codes. These insights are absolutely crucial for maintaining the vehicle's optimal performance, diagnosing issues, and catching potential problems before they lead to a breakdown. You wouldn't drive a car without a dashboard, and you shouldn't run an application in production without monitoring. By leveraging Spring Boot Actuator, you gain invaluable visibility into your application's operational state, allowing you to proactively manage its health, performance, and stability once it's out in the wild. This capability transforms your application from a black box into a transparent, observable system. In our final chapters, we'll briefly look at some advanced Spring Boot features that expand its capabilities even further, and then discuss your next steps on this journey. For further reading, Spring Boot Actuator documentation, docs.spring.io/spring-boot/docs/current/reference/html/actuator.html. Micrometer.io, the vendor-neutral application metrics facade used by Spring Boot for deeper understanding of how metrics are collected. 11. Beyond the horizon. Exploring advanced Spring Boot features. We've covered the core of Spring Boot: building web applications, handling data persistence, managing configuration, ensuring quality through testing, and monitoring deployments. This foundation is solid, but Spring Boot is part of a much larger and incredibly rich ecosystem of tools and frameworks. This chapter will provide a high-level overview of some advanced Spring Boot features and related Spring projects. Think of it as a roadmap to deeper dives, suggesting avenues for your continued learning. These topics are large enough for entire books themselves, so we'll only describe their purpose and how Spring Boot ties into them, without diving into implementation details. Spring Security, guarding your application's gates. Almost every real-world application needs security. It's not just about protecting your data from malicious attacks, but also about controlling who can access what features and information. Spring Security is a powerful and highly customizable authentication and access control framework. Authentication, verifying who a user is. This can involve traditional username-password logins, social logins like Google or Facebook, or modern token-based approaches like OAuth2 or JWTs. Authorization, determining what an authenticated user is allowed to do. This involves defining roles, e.g., admin, user, guest, and then restricting access to specific web endpoints, data, or functionality based on those roles. Spring Boot's role. Spring Boot provides excellent out-of-the-box integration with Spring Security. By simply adding the Spring Boot Starter Security dependency, you can quickly add basic authentication mechanisms, like a default login page or HTTP basic authentication, and then configure more sophisticated access rules with minimal effort. While simple to get started, Spring Security is incredibly flexible and can be adapted to highly complex security requirements. Spring Cloud, building distributed systems and microservices. As applications grow in complexity, they are often broken down into smaller, independent services, microservices. This makes them easier to develop, deploy, and scale. However, distributed systems introduce new challenges. How do these services find each other? How do they handle failures? How do they manage their configurations centrally? Spring Cloud is a collection of projects that provide tools and patterns to address these complexities when building and deploying distributed systems, especially microservices. It essentially gives microservices superpowers to participate in a distributed network. Service discovery, e.g., Eureka, Console. In a microservices architecture, services often communicate with each other. Service discovery allows services to find and register themselves, so they can dynamically locate other services without needing to know their network addresses beforehand. It's like a constantly updated phone book for your services. Config server. Instead of each microservice having its own application.properties/iml, a config server provides a centralized place to manage configuration properties for all your microservices. This makes configuration changes easier and more consistent across your entire distributed system. Circuit breaker, e.g., Resilience 4J. If one microservice fails or becomes slow, it can cascade failures throughout the entire system. A circuit breaker pattern prevents this by quickly failing requests to a misbehaving service rather than waiting indefinitely, and can then retry later, improving the overall resilience of the system. API gateway. When clients, like a web browser or mobile app, interact with microservices, they need a single entry point. An API gateway acts as this entry point, routing requests to the correct internal microservice, and can also handle cross-cutting concerns like authentication, rate limiting, and logging. Spring Boot's role. Spring Boot applications are the fundamental building blocks, the individual microservices, that are then orchestrated and enhanced by Spring Cloud components. Each microservice is typically a self-contained Spring Boot application. Spring Batch, handling large-scale data processing. Not all applications are web services. Many involve processing large volumes of data in an automated fashion, without direct user interaction, e.g., end-of-day financial reconciliation, data migration, generating complex reports. Spring Batch is a comprehensive framework specifically designed for robust, high-volume, and performant batch processing. It provides reusable functions and patterns for handling various aspects of a batch job. Reading data from diverse sources, databases, files, message queues. Processing data, transforming, filtering, aggregating. Writing data to different destinations. Managing transactions, logging, tracing, and restarting failed jobs from the point of failure. Spring Boot's role. Spring Boot simplifies the setup and running of Spring Batch jobs, making it easy to create executable applications that perform these complex data processing tasks. Asynchronous processing at a sink, improving responsiveness. In a typical web application, when a user makes a request, the executing code runs synchronously one step after another on a single thread. If one part of the request involves a long-running operation, like sending an email or performing a complex calculation, the user has to wait until that operation completes before receiving a response. Asynchronous processing allows certain tasks to be executed in the background on a separate thread without blocking the main request thread. This improves the responsiveness of your application, especially for user-facing actions. Spring Boot's role. Spring Boot provides a simple, annotation-driven approach for asynchronous execution using @enable async to enable async capabilities in the application, and @async placed on methods you want to run asynchronously. For example, after a user successfully signs up, you could immediately send a 200 OK response, while the email verification process is launched asynchronously in the background. The broader Spring ecosystem. A glimpse of depth. The Spring ecosystem is incredibly vast, with specialized projects for almost any enterprise development need. Here are just a few more that demonstrate its breadth. Spring Webflux, a reactive programming alternative to Spring MVC for building highly concurrent and scalable web applications. Particularly useful for high-throughput, low-latency scenarios where the traditional synchronous model might become a bottleneck. Spring Integration, a framework for implementing enterprise integration patterns, helpful for connecting different systems and applications through various messaging and data flow patterns. Spring Data Beyond JPA. While we focused on Spring Data JPA, the Spring Data Umbrella project provides similar simplified data access for a wide array of other database technologies, including popular NoSQL databases like MongoDB, Redis, and Cassandra, as well as graph databases. Spring State Machine, for defining and managing complex state-based behaviors in your applications. Spring GraphQL, for building GraphQL APIs with Spring applications. This list is just the tip of the iceberg. Each of these projects integrates seamlessly with Spring Boot, allowing you to add sophisticated functionality to your applications with the same developer-friendly experience you've learned about. This chapter should give you a sense of the vast capabilities that extend beyond the core Spring Boot framework. As your application needs grow, you'll find that the Spring ecosystem likely has a well-tested and robust solution, and Spring Boot will help you integrate it smoothly. In our final chapter, we'll summarize our journey and offer advice on continuing your Spring Boot adventure. For further reading, Spring Security Project page, spring.io/project/spring-security, Spring Cloud Project page, spring.io/project/spring-cloud, Spring Batch Project page, spring.io/project/spring-batch, Spring Guides, spring.io/guides, for quick, practical examples of specific Spring projects and features. 12. Your next mission, continuing the Spring Boot journey. We have reached the end of our exploration into the Spring Boot framework. From setting up your development environment to understanding its core principles, building a functional web application, integrating a database, and even touching upon deployment and monitoring, you've gained a foundational understanding of what makes Spring Boot such a powerful and popular tool in modern software development. Recap of key takeaways. Let's quickly revisit the major concepts we've illuminated throughout this book. Spring Boot simplifies Java development. It cuts through the traditional complexities of Spring's configuration, allowing you to focus on application logic rather than boilerplate. Auto-configuration and starters are the magic. These features streamline dependency management and automatically configure common functionalities, rapidly accelerating your development process. Building RESTful APIs is straightforward. Spring Boot provides intuitive ways to define endpoints, handle various HTTP methods, and convert data to and from JSON, forming the backbone of modern web services. Data persistence is elegantly handled. With Spring Data JPA, you can interact with databases using familiar Java objects, leaving the SQL complexities to the framework. Externalized configuration and profiles make applications adaptable. You can easily tailor your application's behavior and settings for different environments, development, testing, production, without altering your code. Testing is built-in and essential. Spring Boot provides robust tools and approaches for unit and integration testing, ensuring the reliability and maintainability of your application. Deployment is remarkably simple. The executable jar, with its embedded web server, makes your application self-contained and highly portable, ready for traditional servers or modern cloud-native environments. Monitoring is production-ready. Spring Boot Actuator offers invaluable insights into your application's health, performance, and operational status once it's deployed. The Spring ecosystem is vast. Beyond the basics, Spring Boot is your gateway to a rich collection of projects like Spring Security for powerful authentication and authorization, Spring Cloud for building distributed microservices, and many others. You now possess the foundational knowledge and conceptual understanding to confidently build, test, and deploy Spring Boot applications. You have seen how Spring Boot streamlines every stage of the development lifecycle, transforming complex tasks into manageable steps. Your next mission, continued learning and practice. This book has provided a solid launching pad, but the journey of becoming a proficient software developer is a continuous one. The world of technology, and particularly the Spring ecosystem, is constantly evolving. To truly master Spring Boot and excel in your field, you must continue to explore and practice. build personal projects. The best way to solidify your understanding is by applying what you've learned. Start with small projects that have a clear goal: a simple blog, a task manager app, a recipe book, or an inventory system. As you encounter challenges, you'll naturally delve deeper into specific features. Experiment fearlessly. Don't be afraid to try out new features, integrate different libraries, or break things in a controlled environment. Experimentation is crucial for learning and understanding. Read the official documentation. The Spring Boot documentation is excellent, comprehensive, and always up to date. As your needs become more specific or advanced, the official docs will be your ultimate authority. Explore Spring Guides. The spring.io/guides section offers numerous small, focused, and practical tutorials that walk you through specific features, integrations, or use cases. They are brilliant for hands-on learning. Engage with the community. Forums like Stack Overflow, Reddit communities, e.g., R Spring Boot, R Java, and various online developer groups are invaluable resources. Learning from others' problems and solutions is a powerful accelerator. Stay updated. Follow the Spring blog, spring.io/blog, for announcements, new features, and deeper technical insights from the Spring team. Consider broader topics. Once you're comfortable with Spring Boot, explore related concepts like Docker and Kubernetes, deep dives into containerization and container orchestration. Cloud computing. How to best leverage platforms like Oz, Azure, or Google Cloud for deploying and managing applications. Microservices architecture. Understanding the patterns and challenges of building large-scale distributed systems. Testing methodologies. Exploring advanced testing techniques and strategies. Your path ahead. Spring Boot is not just a framework. It's a gateway to building powerful, scalable, and maintainable applications. The skills you've gained can open doors to exciting career opportunities in backend development, microservices, cloud engineering, and many other fields. The demand for skilled Spring Boot developers remains consistently high. This book has provided you with the keys to the Spring Boot reactor. You've learned how to start it, understand its core systems, and even make it perform basic functions. Now, it's time to open your IDE, roll up your sleeves, and embark on your next mission, building your own compelling applications and continuing your exciting journey in the world of modern Java development. Go forth and build. For further reading, Spring Academy. Spring Academy for official training and certifications from VMware Tanzu/Spring. Major cloud provider documentation, e.g., AWS, Azure, Google Cloud. Explore their sections on deploying Java applications for specific guidance. GitHub, a fantastic resource to discover open-source Spring Boot projects and examples that demonstrate real-world usage of the framework.